measurement and control in oil and gas is going to help you out throughout the career while you are going to select, design, or procure any instrument related to the temperature in oil and gas industry. Okay, so please be with us. We are going to give you the brief topic discussion related to the temperature, and the agenda of this webinar are following. What is temperature measurement in oil and gas industry? What are the different type of temperature measuring instrument we do use in the oil and gas industry? Those are bimetal dial thermometer, gas field dial thermometer, liquid field dial thermometer. Apart from that, there are some indicating temperature switches, RTDs, that is resistance temperature detector. There are some Thermowell dimensional details which we are going to discuss over here. This Thermowell is very important related to the temperature instruments, because the temperature instrument selection is going to be depend upon this thermowell dimension and their details. So while we are going to discuss the thermowell dimensional detail, we will also discuss about the U length calculation of the thermowell. Like most of the people are keen interested to know that how do we select the length of the thermowell, because once you will select the length of the thermowell, then only you will be able to select your RTD stem length, temperature gauge stem length, thermocouple stem length, and all those things. So we will discuss those U length calculation of the thermowell as well. Also, while we are selecting the thermowell, we also have to do the wake frequency calculation of that thermowell, that either that thermowell is suitable for our process condition or not. So these things are also we are going to discuss over here. The thermocouple detailed discussion we will do over here. Apart from this, all these temperature measuring instruments, the material requisition, that is request for quotation process, we will discuss that how do we prepare the material requisition, how we will do the technical bid evaluation, that is TBE, we say TBE or TBA. Okay. After that, vendor document review, that what are the different process to do the vendor document review. Okay, so these are the agenda which we are going to discuss over here, and this is certainly going to help you out throughout your career. And yes, we are proceeding further to our next slide. So first of all, we will discuss what is temperature. Okay, so temperature is defined as measure of thermal energy of an object. Any object which is having some thermal energy, those energies are called temperature. Okay, so unit of the temperature is Kelvin. Okay, and degree Celsius, Fahrenheit. There are different units of temperature we are using worldwide. Okay, so as per our convenient, as per our choice, we can go with any units which we are using over the world. Now the temperature is having a certain properties, like it will flow from hot body to cold body. If you are having a hot material and if you are having a cold material, so temperature or heat will transfer from hot body to cold body, so we say that temperature is being transferred. Once this both material will come at the same temperature, so there will be equilibrium between them. Okay, so these are the some points regarding the temperature. Now we will talk about the SI units of the temperature. So what is the SI units of the temperature? Most of the time in the interview, interviewer also asks that what is the SI unit of the temperature. Okay, in international system, the SI units of the temperature is Kelvin. Okay, and that is denoted by K. Okay, so other units are also there, that is degree Celsius, Fahrenheit, Rankine. So see, sometimes what happen, like if we are using we are having some process parameter in degree Celsius, but we have to mention our temperature in the degree Fahrenheit. Okay, so in that case what we need to do, we have to convert this degree Celsius into degree Fahrenheit. So there are some relationship between the different units of temperature through which we can proceed to, through which we can convert the temperature value from one unit to another unit. These are some basic information about the temperature. Now we will come to the point, like type of temperature measuring instruments which we are going to discuss over here. So temperature gauge. Okay, so most of you have seen at the site, at commissioning site or any project site, or either in design department, like what are the different instruments we are using to measure the temperature in the industry. So the temperature gauge, that will be three type of temperature gauge we will discuss over here. Indicating temperature switches. Okay, indicating temperature switches. Then after RTD. Okay, RTD, Then after thermocouple, we will discuss thermocouple, Thermowell. Okay, then thermistor. These are some different thermistor which we use to just cut off the any instrument. Like we are having a free refrigerator, we are having AC in air condition in our room. So after achieving certain temperature, thermistor just cut off the power supply and the compressor will be stopped. Okay, so that is your thermistor. Nowadays, in during the COVID time, this infrared temperature sensor is very popular. Like without touching any surface, it can measure the temperature of any surface. Okay, so these are also very popular. Okay, so first of all, we are going to discuss about the bimetal dial thermometer, that is temperature gauge. So the name suggests bimetal dial. That means there are two metal strip, bimetal strip, and that will be in the form of helix. That will be in the form of helix, and it will be work on the principle of thermal expansion. Means if there is two different metal having different coefficient of expansion, so the resultant expansion of bimetal will be proportional to the temperature. Okay, so whenever we are having option to measure the temperature from minus 50 degrees Celsius to 600 degrees Celsius, we can go with the bimetal dial thermometer and it will work very well. Also, this temperature gauge is this temperature gauge is uh, going to use for the local measurement. Means temperature gauge don't have any cable wire, it is not going to send any signals. So we can say that this instrument is basically the mechanical instruments. Means this instrument is not going to send any signal to the control system. This instrument is not going to control any temperature process or any process. So it will be used only for the local measurement. Means the person who is in the field, they can locally look in the glass of the temperature or reading of the temperature on the scale of the temperature gauge, and they will be able to understand that what is the temperature inside this process. On the on that process, this instrument is mounted. So guys, whenever you are having option to measure the temperature from minus 50 degrees Celsius to 600 degrees Celsius locally, then you can go with the bimetal dial thermometer. Okay, there are some detailed specification of bimetal dial thermometer, like its manufacturing standard. Means what is the reference standard for this temperature gauge. So the reference standard will be ASME 40.200 and EN 13190. Okay, now as per these standards, the dial size of the temperature gauge is coming in the form of 100, 150, 250 mm, aluminum white background, black marking. So when you are going to choose the dial size, obviously the dial size will depend upon our choice. Whatever the choice we are going to choose, the manufacturer will offer you the same. Okay, the case material will be available. This is your case material of the temperature gauge. So the case material will be SS304 in general, but if we need to select the SS316, that is also available with the manufacturer. But see, this case material is not coming in the contact of any process fluid. So if we are going to use SS304, that is not a big deal, or that is not a big problem for us. Okay, now the protection. So since this instrument is an enclosure, so this enclosure needs some protection. What kind of the protection we need? Since this instrument is not connected with any cable wire, so there is no such kind of hazard possible. Most of the guys have a confusion, like we need to take the exd protection, we need to take exi protection, exis protection. So those protections are basically intrinsically safe protections. So increased safety protection, so those protections are basically for the hazardous area classification. Since this instrument don't have any wire or cable connected with this instrument, so there is no such possibility of a spark. And if there is no such a spark is there, there will be no hazard. So if there is no hazard, so we need not to select the hazardous area classification for this instrument. Okay, so what classification we need to choose for this instrument? So those classification is your weatherproof classification, because this temperature gauge you are going to mount in the field or in the outside of your plant with a open sky. So in that case, you need to take care of the weather protection, that is IP protection, ingress protection. Okay, so there is a separate class in our training session for this weather protection, in which we discuss in detail about the hazardous area classification for all the instrumentation design. Okay, Then the glass of the material, that is temperature glass material. What is the temperature glass material we will choose? So there is a shatterproof glass, okay, pointer aluminum, black, micrometer adjustable. Means this glass will be shatterproof. There is some properties of the shatterproof glass. What are those properties? Like if this glass will be broken out in any certain cases, so there will be a smaller pieces will split out. Okay, means this glass will not come in the big pieces, and it is not going to hurt or damage any person nearby working. Okay, like your car mirror or car window. If car window broken out, it will becomes a crystal, smaller crystal. It is not coming in the big piece of the glass. So those are shatterproof glass. This is the stem of the temperature gauge. Okay, so this is the stem of the temperature gauge. So obviously now this stem material is going to insert inside the process fluid. So that can be 304 316 as per our process parameter requirements. Okay, now why we stop till 304 and 316? Why not we go for the monoel, histoloy and inconel and all those higher grade of the material? Because this stem is going to be covered with the thermowell. So since this stem will be covered with the thermowell, so the classification of this material is not need to be taken higher class of the material. Means I mean to say this material, this stem material need not to be take for the higher grade of the material, because it is already being protected with the thermowell, and the thermowell will come in the contact of the process fluid. This stem material is not going to be come in the contact of the process fluid. So that is why this 304 and 316 is going to help you out. Now the diameter of the system, this is very crucial point for you to understand over here, that this diameter you cannot choose from yourself. There are various offering from the vendor side, like 6 mm, 8 mm, 10 mm, 12 mm. Different diameter sizes are available, but you will select the diameter size only after finalization of the thermowell. Because once you will finalize your thermowell, then you will be able to understand that what size of the stem will insert, it will be easily inserted in the thermowell. Because thermowell will depend upon the various process fluid. Okay, thermowell is going to depend upon the various process fluid. Thermowell dimension will depend upon the various process fluid. So in that case you will have to select this stem diameter as per thermowell dimension. Okay, not as per this dimension we will select the thermowell, we will select the this dimension as per thermowell. Correct. Again the same thing is length of the stem. So this length of the stem will again depend upon the u length of the thermowell. So that we will discuss during the thermowell discussion. Okay, there are various connection size available with the manufacturer. So whatever is your connection size, whatever the philosophy you are following in your project for the connection size. So now the question is, if from where you will get the connection size, like how you will know that what connection size I should choose for particular thermowell. So guys, the connection size is generally mentioned on the PNID also. Okay, and these are also available in your instrumentation design basis, that what are the different process connection size we will have to adopt for different kind of the material instrument, like temperature instrument, pressure instruments, flow instruments. Okay, all those things. Range we have already discussed. Okay, now the accuracy of the thermowell is plus minus 1% of full scale deflection. Means this is your full scale deflection. So this temperature gauge will give you 1% error while you are measuring any temperature. Suppose your temperature gauge is showing you 50 degrees Celsius temperature, that means that temperature may be plus minus 1% wrong. Okay, so overrange protection is also crucial factor while selecting you any gauges. Like the overrange protection means if you are selecting this thermowell for 100 degrees Celsius temperature, although if you are selecting the overrange protection 25%, that means although this thermo temperature gauge will measure the temperature up to 100 degrees Celsius, but it will work or it can sustain the temperature up to 125 degrees Celsius. That is your overrange protection. Okay, there is a reset micrometer pointer for the thermo temperature gauge, which can easily be used to reset the temperature gauge. There are some optional options available with the temperature gauge, like silicon oil filled case. So why we will go with the silicon oil filled case in the temperature gauge? Because silicon is known as the cooling agent in our microprocessor or various places. We use silicon as a cooling agent. Okay, so this temperature this silicon oil filled case will just give a temperature gauge pointer stability while we are going to use any vibrating services or any vibration we will feel, then we can use this silicon oil filled case as a optional. Okay. Nowadays the temperature gauge is also coming with the switches, because most of the people has confusion, like a temperature gauge is coming with a wire and a cable, temperature gauge is coming with cable. How? So if the temperature gauge is coming along with the switches, so in that case the cable will be available in that. So the switches specification we should select like this. Now we will discuss about the gas filled dial thermometer. So guys, I have discussed this bimetal dial thermometer in detail. Why? Because the other temperature gauge are most more or less similar to that. Okay. So gas filled dial thermometer. What is this gas filled dial thermometer? So in the gas filled dial thermometer will overcome limitation of other member of this family, as its temperature range is very wide. Okay. The temperature measurement range is belongs from minus 200 degrees Celsius to 800 degrees Celsius. So in such application, especially in the cryogenic application, we will go with this gas filled dial thermometer. Now again question may come in your mind that what is the cryogenic application. So any process fluid which is below minus 29 degrees Celsius, those process fluid are called cryogenic process fluid. So most of you have heard the word LNG, that is liquefied natural gas. Their temperature is minus 196 degrees Celsius. So that is called a cryogenic process fluid. Okay. Now, this gas filled dial thermometer is also coming in the form of capillary, and this capillary length can go up to 30 meter. Okay, so there is also advantage, like if we are not able to install the temperature gauge online, so we can take it temperature gauge to mount it remotely. We will insert this probe in the process connection, and we will take it through the capillary to any remote location. Okay. So gas filled dial thermometer, the inert gas will be used, that is nitrogen. Okay. Again, their IP protection accuracy class we need to take care. Their reference standard is same. There is some special standard which will be used for this gas filled dial thermometer, that is your SAMA class 3B. So this is also very important. This SAMA class is basically the Scientific Apparatus Makers Association. There is a standard through which this gas will be filled inside this gas filled dial thermometer. So the SAMA class 3B is applicable while we are going to manufacture this gas filled dial thermometer. Their dial size, case, protection, window, pointer, stem, all those are similar to the earlier one. Okay. The next special thing or some different thing from first one is the capillary, because this temperature gauge, that is gas filled dial thermometer, is coming in the form of capillary also. So in that case there are various capillary option available with the manufacturer. So whatever is our choice, whatever is our requirement, whatever is our client recommendation, so in that case we can go with this capillary. Okay. Now, as discussed earlier, also the connection size, different connection size are available. So the manufacturer can offer us the different connections as per our project philosophy, as per our requirements, accuracy, overrange protection. These things we have discussed already in the temperature gauge. Okay. Next one is your liquid filled dial thermometer. So what is this liquid filled dial thermometer? This thermometer or this temperature gauge will work for minus 30 degrees Celsius to 250 degrees Celsius. It is also available in the form of capillary. Okay, and their capillary length can go up to 5 meter. Okay, so these are the limitations with this liquid filled dial thermometer. Their specification will be similar to the gas filled dial thermometer. Only one thing is different over here. What is that? That is SAMA class 1B. Means this liquid will be filled in this temperature gauge as per SAMA class 1B. Okay. So these are the different difference from the earlier one, that is gas filled dial thermometer, and their range is also less. Means it will work for minus 30 degrees Celsius to 250 degrees Celsius. Okay. So these are the temperature gauge which we have discussed right now. That is bimetal dial thermometer or temperature gauge. Then after your gas filled dial thermometer, and then after liquid filled dial thermometer. So these are the thermometer we use in the industry while we are going to check the temperature on any line locally. But if we need a switching action, if we need a high alarm, low alarm values at our DCS, so in that case we will go with the switches. Okay, so switches can give you the point measurement. The gauges will give you the local measurement, the switches will give you the point measurement, and transmitter will give you the continuous measurement. So this switch will only give you the low alarm value or high alarm value, whatever you will set inside this. Okay, so these are different switches available in the industry, okay, to measure the temperature. But the accuracy of switch is little bit lower, means its accuracy will be plus minus 2% of FSD. That means it will show 2% error while it will select it will measure the temperature. Okay, now this temperature switches having case material, although this case material now you will have to select very carefully. Why very carefully we should select the case material? Because this switch will be connected with the cable. So once there will be cable connected to any instrument, not only switch, any instrument, if it is going to be connected with the cable, so in that case, in oil and gas industry, you will have to consider the hazardous area classification. So those case will be selected while considering keeping in the mind hazardous area classification. So this case material can be die cast aluminum enclosure, epoxy powder coated, IP rating will be there. Okay, the this die-cast aluminum enclosure will have some flame-proof specification like gas group specification, temperature class specification. We will need to specify. Okay, so all these flame-proof apparatus requirements we need to specify while we are going to select this temperature switch, because hazardous area is very crucial thing for oil and gas industry, and it is also a big, not topic, big subject for the industry, because every industry has to keep in their mind the hazardous area classification, because a small hazard can make you a bigger trouble or can make you a biggest problem in your plant. Okay, so cable entry size, different cable entry size available with the manufacturer. Stem length, stem, their stem will be different. Connection size, capillary, ranges. Okay, so the temperature switch ranges we will select as per our high and low value. Okay, so the temperature switch range will be selected in such a way that our low value, low alarm value and high alarm value will come under this 10 to 90%. Suppose if you are having 88 we can say degree Celsius temperature as a high alarm, so in that case we can use 0 to 100 degree Celsius temperature switch range. Okay, because its low alarm value should more than 10 and high alarm value should less than 90. So in that case we can go with the 0 to 90, means this set point should come in between 10 to 90% of the selected value. So the range will be selected in such a way that the 10 to 90% will be the set point values comes between the 10 to 90%. Again, this switch having some rating, power rating is there. So those power rating might be 220, 120, 110 or 24 volt. Okay, and their switching type we need to specify. Whatever the switching type we are going to select for our requirements. Now we come to very important thing, that is your RTD, resistance temperature detector. So what is this RTD? Why the, as you have seen that for the local measurement we have gone with the temperature gauge, for point measurement we have gone with the temperature switch, for the continuous measurement we will go with the RTD with transmitter, because RTD can also transmit the signal to the control system. So the ways to connect this RTD with the control system are two. There are two ways to connect this RTD with the control system. First way is directly you connect your RTD with junction box, and junction box will connect, cable will connect from the junction box to the control system. But in this case we are not using any transmitter, so in that case we need to use a RTD card at the control system end. So here we are saving the money or cost of the transmitter, so we need to imply the RTD card over the control system. But if you are using this RTD and the signal of RTD will go to the transmitter, so in that case once the signal will reach to the transmitter, after that the signal will be your conventional system signal like that. So in that case the transmitter signal will be connected to any nearby JB, and that JB will be connected to the control system, and there is no such card is required at the control system. So convention is depend upon us, like how we are going to select the RTD connections in the project. There are different part of the RTD. So this RTD basically having some sensing element. Generally, in 99% cases, at the tip of the RTD, we use a sensor, and that sensor is your PT100. So what is this PT100? Platinum 100, that will be show you 100 ohm resistance at 0 degree Celsius. This point is very, very important. Keep in your mind, because always you will face this point in your working life or working culture or in interview also. Like interviewer asks that what do you mean by PT100, or what kind of the sensor we will use for the RTD. So the generally we use the PT100, that will show you the 100 ohm resistance at 0 degree Celsius. As the temperature will increase, the resistance will also increase. Okay. So this RTD will be inserted inside the thermowell. So this gray part you have seen here, this gray part is your thermowell. Okay. So inside the thermowell, this RTD probe is connected. So this is RTD sensing element here. Okay. Insulated lead packed magnesium oxide. So the RTD will be sensor will be connected with this sensor will be connected with uh, uh, virgin copper conductor. What do you mean by virgin copper conductor? That means there will be no any PVC insulation over the conductor. So that conductor will be virgin. So if there is a two conductor of copper inside this stem, so that will come in the contact, and they will touch each other, and there will be shorted. So to make it insulated, we will use the magnesium oxide, that is 99% pure, which will be insulate this virgin copper inside copper wire inside the RTD stem. Okay, this is your RTD probe sheath. Okay, this is called your RTD head. So this is your RTD head. There is a connection head terminal where the cable will be terminated. Okay, so these are the construction of the RTD. In the RTD, there is a sensor part element. That is element may be simplex, duplex, or triplex. It will depend upon our criticality of the process, like how much critical process is. On the basis of that, we will select this simplex, duplex, or triplex requirements. There are 2 wire, 3 wire, 4 wire RTD also. Okay, so as per our requirement, as per our convenience, as per our system requirements, or as per our criticality, we will go with the 2 wire, 3 wire, and 4 wire RTD. So during the discussion of the class, we will discuss too much detail about the simplex, duplex, PT100, through 2 wire, 3 wire, 4 wire RTD, their calibration standards. So RTD will be calibrated as per IEC 60751 standard, class A or B. There are different sheath material available, sheath dia available, material available, head material, number of cable entries, that is single or duplex, cable entry size are available, head type having a different protection class as per hazardous area classification are there. So these details are going to specify you the selection of the RTD for your process requirements. Okay. Now this RTD stem will insert inside the thermowell. Okay, so we come to the thermowell. So what is the thermowell? It is a physical instrument which will just protect your RTD stem from getting damaged. Okay, so thermowell having a different dimensional part, like your this is your tip diameter, this is your tip thickness of the thermowell, this is your tapered length, means this thermowell will be tapered up to 150 mm. Then after U length of the thermowell, so this is your U length of the thermowell. Always it is being asked in the interview that what is the U length of the thermowell. So U length of the thermowell is total length from bottom, means tip of the thermowell, to the flange of the thermowell. So in this figure you will also able to understand that U length will be from here up to this flange. So that complete length is U length. In another words, you can say that U length is your nozzle length. This is your nozzle in which the thermowell will be inserted. On the pipe there is a pipe, on the pipe there is a nozzle, inside the nozzle the thermowell will be inserted. So this U length is the nozzle length plus the insertion length or immersion length. Some people say immersion length, some people say insertion length. So immersion is the proper way. Like immersion length means the part of the thermowell which is immersed or it will be deep inside the pipe. So the length, this length plus the nozzle length is the U length of the thermowell. This is the neck dia of the thermowell. Okay, this is the ID of the thermowell. Okay, and this is the neck dia of the thermowell. Okay, so these are the dimensional detail of the thermowell. These are the dimensional detail of the thermowell which we are showing to you. Now the calculation of the thermowell U length will depend upon the pipe diameter. Okay, so how do we select the thermowell U length as per pipe diameter? So the conventional theory is that the thermowell will be selected, U length will be selected on the basis of pipe diameter in such a way that the this insertion immersion length should be minimum one third of the pipe dia or maximum two third of the pipe dia. Means suppose your pipe dia is 100 mm, so we can say one third of the immersion means 33 mm is the immersion length inside the pipe minimum, and 33 mm is the minimum immersion side, and 66 mm will be the maximum immersion size we can take for the thermowell. Okay, now the thermowell nozzle length will be added inside this for calculating the U length. So the nozzle length will again depend upon the project to project. If your project having some insulation, so you will have to keep the nozzle little bit longer. If there is no insulation, so you can keep the nozzle shorter. Okay, so this nozzle length varies from 100 mm to 250 mm up to 250 mm. It will depend upon our philosophy, that what philosophy we are using in the project. Okay, so the total length, that is immersion length plus this nozzle length, will be the thermowell U length. In this case, suppose this is your 100 mm pipe dia. So in this case, there is a minimum 33 mm immersion and maximum 66 mm immersion, and 200 is the nozzle length. So total length is 233. Minimum will be 233 and maximum will be 266. But in general, client what they want to do, or what they do, they don't want to make the thermowell for select the thermowell for different pipe size for different length, or they may also select that different length. But in a standardized form, if we talk about the India or some EIL standards, so EIL specifies it a standard length, like they will specify this U length for the thermowell for 4 inch to 6 inch pipe dia up to 280 mm. Okay, for 8 inch to 12 for 8 inch and above, they will specify 320 mm U length. Okay, and for the nozzle and vessel, they specify 400 mm U length. Out of that 400, the 200 will be the nozzle length and 200 will be the immersion length. So by this way, we will decide the thermowell U length. That is keeping in mind, what we will keep in the mind, like one third minimum immersion and two third will be the maximum immersion plus the nozzle size or nozzle length. That will be the U length of the thermowell. So please don't confuse while we are discussing, or while anybody will ask you that thermowell U length, about the thermowell U length. Also, there is one very popular question in the industry or in the market or in the interview. People ask that if we are having 2 inch pipe size, so how do we connect that thermowell in that? So guys, thermowell cannot be inserted below 4 inch pipe dia. If your pipe dia having less than 4 inch, so in that case we cannot directly insert the thermowell in that line. So in that case, we need to use the expander to expand the pipe dia up to 4 inch. Then only we will insert the thermowell inside that. We cannot insert the thermowell below 4 inch line size. So hope it is clear to all of you. Now there is one point very important for the thermowell, like you are going to select the thermowell. So the strength analysis calculation of the thermowell very important, because this thermowell is directly going to be inserted inside the nozzle of the pipe, and it will be experience various velocity. It will experience the velocity, density, viscosity, temperature and pressure inside the pipe. Okay, so it need to be check its strength while we are designing this thermowell. So what we do, we check the thermowell strength analysis calculation or wake frequency calculation as per a standard, and that standard is ASME PTC 19.3 TW 2016. This is the latest standard 2016. Earlier it was 2010. Okay, so always it will be asked to you that what is the standard through which we will do the wake frequency calculation or strength analysis of the calculation of the thermowell. So that will be as per ASME PTC 19.3 TW 2016. So these are some vibration in the nozzle of the thermowell. If you will select the wrong thermowell, there may be some wear and tear at the neck of the thermowell due to the wrong selection. So while we will do this wake frequency calculation of the thermowell, what we need to do, we need to first of all specify the dimension of the thermowell. So that first we select that we will going to select this dimension of the thermowell, any xyz dimension of the thermowell. So that calculation will be done as per SME PTC 19.3 on the some calculation tools. You may search on the Google. There are various tools available with Astrof, Vika, like that, how to calculate the thermowell. Wave frequency calculation calculator is available over there. So in that wave frequency calculation, you need to specify the thermowell dimension, their process condition, Okay, once you will specify the dimension and process condition, and once you will run the software, it will give you some values, and that values are basically the frequency of the thermowell, their oscillating stress, steady stress, pressure and frequency. So these values are not going to give you the result ki either this thermowell is passed or failed in the wave frequency calculation, but the status will show you that either this thermowell is fail or pass in the process given process condition. Okay, another point which is very very important, that is the frequency of this thermowell strength analysis. So this frequency of this thermowell strength analysis in general, for most cases, in general cases, it should be below zero point 0.4. Means frequency should be below zero point 0.4, then that thermowell is accepted. If frequency is more than zero point 0.4, so in that case we are not going to select that thermowell, and that thermowell will show you the failed over here. Okay, the process status will be failed. So once the thermowell selected, you have selected that thermowell that is failed in your process as per your process condition. So in that case you need to change your thermowell dimension, their metallurgy. So how we will change the dimension, how we will change the metallurgy, that we will discuss in the detail class while we will take the temperature instruments class in our instrumentation design training. So in the instrumentation design training, all these parts whatever we are discussing here, these are the just your summary of the all technical information which we will discuss during the class, because during the class it will give you the brief information about these technical things, and it will be 100% going to help you out during your instrumentation design engineer career. Okay, now also it will be asked during the interview that what are the different process parameters which are crucial while we are selecting the thermowell. So guys, for selecting the thermowell we are having some crucial process parameter, that is process fluid type, their maximum temperature, minimum temperature, their velocity, their density, their viscosity. These are the points which are very very crucial while we are going to select the thermowell design. Okay, material of the thermowell will be 100% depend upon the process fluid temperature and pressure and their chemical properties. Okay, so these are the thermowell wave frequency calculation we do in the industry. These are the frequency ratio which should be below zero point 0.4 while we are selecting the thermowell. Now another point is our thermocouple. So what is the thermocouple? So first question is ki when we will use the thermocouple. Thermocouple is also a instrument which will measure the temperature, but when we will use the thermocouple, so if you are having a temperature range of higher degree, higher class of the temperature you need to measure, so in that case we can go with the thermocouple, because your temperature RTD, because your RTD was going to use the temperature up to 550, means minus 200 to 550 degrees Celsius temperature it will measure only. Okay, after that it is not going to measure temperature. Their limitation is up to 550 degrees Celsius. So if you are having a temperature more than 550 degrees Celsius, so in that case we can go with the thermocouple. So what is thermocouple? Thermocouple is an electrical device or sensor which measure temperature. Okay, it is having a very wide range of the temperature measurement. It will work on the principle of Seebeck effect. Okay, and it consists of two dissimilar conductors forming electrical junction at different temperature. So these two different metal having a different temperature, so it is connected to a point and it will form a junction. So this junction is called a hot junction and this junction is called a cold junction. Okay, so the thermocouple produces a temperature depend upon the voltage as a result of the thermoelectric effect. Okay, and the voltage can be interpreted to measure the temperature. Okay, this is your hot junction, this is your cold junction. So different temperature we will apply over here. So the difference of the temperature will be measured in the form of the temperature. Okay, so thermocouple sensors material having a different type of alloys, that may be a nickel alloy thermocouple, platinum rhodium alloy thermocouple, tungsten rhenium alloy thermocouple. So this nickel alloy thermocouple having a different thermocouple in the industry which we are widely being used. Okay, in the oil and gas industry most of the time we use this type of the thermocouple like E type thermocouple, J type, K type, M type, N type and T type, and all these thermocouple having different temperature range. Like if you talk about E type thermocouple, so it will have a chromal constant 10 and non-magnetic having a range of minus 50 degrees Celsius to 740 degrees Celsius. Okay, type J type having some different temperature range, K type, M type, N type and T type, all these temperature thermocouple have a different range of the temperature. Okay, so as per our temperature measurement requirement, we will go with the type of the thermocouple which we need to select. There are some thermocouple type, their temperature range, their sheath OD available, sheath material available, their standard limit of error means how much error it can give you. Okay, and what are the limits of error? So these are the table that will specify the different range, the different type of the thermocouple which widely we are being used in the industry. Now guys, once you decide your instrument, temperature instrument like temperature gauge, temperature switch, RTD, Thermowell, your thermistor, your infrared sensors, your we can say Thermowell, your transmitters. So all those instruments need to be procured in the industry. So what are the process to procure that material? So that procurement part we are going to discuss over here. That is, your material requisition is the first process, and this procurement process is very very crucial. If you know this procurement process in the industry, you will be the leader, because the final aim of the instrumentation design engineer to design, to select the correct material, type of material should be correct, the range of the material should be correct, the material of the material instrument should be correct. Okay, so all those things once we decide, so the next step is to procure that material. So for the procurement of that material, first we need to prepare the requisition, material requisition, that is called MR, and the request of quotation, that is called RFQ. Okay, so material request is a process through which we prepare and share our requirements with the supplier or vendor. Means suppose you are going to procure RTD. So what is our requirement? Either we need to take the single RTD sensor or duplex or triplex RTD sensors. We need PT100 or some other sensors. Okay, we need a stem dia. What is the stem dia? What should be the stem length we should take? Okay, what will be the grade of the material? What will be the RTD sensor stem material? What will be the RTD we can say head material? What will be the connection size? So all those things we need to give to our supplier or vendor. So in the engineering, procurement and construction, like even EPC industry, to prepare the MR, to prepare the request of quotation, first of all we need to give the project information in that MR, like for which project we are going to procure, where the material will go, what is the site conditions, all those things. Then what are the item we are going to procure with this MR? If suppose you are preparing any MR, so what are the different items you are going to procure, that we need to specify in our MR. Then technical specification, what is the technical requirements of that material which we are going to procure. Any drawing or document of that material we need to attach with this MR. Any specification, any standard that we need to add with the MR. Any client reference, any client specification, that we will also add with this MR, material requisition, so that at the end of the day vendor should not deny it, no, this information was not shared to me, so I was not aware about that. After doing this all these things, the delivery requirement we will have to mention in our MR, like when we want to take this material from the vendor, what is the inspection and testing requirements which we need to take from the manufacturer. What are the packing and shipping instruction to the vendor? Either vendor has to pack that material in a metallic box, either it will be packed in the any wooden box, or either it will be packed in any cartoon, or either it will be packed in a bag packets. Okay, so different packing and shipping instruction that we need to share, because all these things which we are going to discuss. Also the documentation requirements, like what are the different documents we will take from the manufacturer. Like manufacturer need to give us the only soft copy of the documents, all those documents like the test certificates, GA drawing, data sheet, and all those materials, inspection materials, documents, or they need to give the hard copy also. So all these information having a price impact of our material. Suppose your project location is very very far from the manufacturer factory or manufacturer works, so in that case the delivery means transportation cost will be high. Okay, if your technical specification is higher grade, so the price will be high. If drawing and documents requirements is much and more, so in that case if your faster delivery is required, so in that case also the price impact will be there. If you are asking about some special inspection and testing, so for that also the price impact will be there. If you want some special packing and shipping type, so in that case the price implication will be there. Documentation requirement also impact the price. So all those things we need to specify in the material requisition while we are preparing the material requisition, so that vendor can easily calculate their cost of the material, and then they can give us the technical as well as commercial offer. So this is the process these are the things which we should keep in our mind while we are preparing MR and RFQ for the material. And every company have their own format in which the MR and RFQ is being prepared. Most of the companies are nowadays using some software to raise the material requisition or request of quotation. So that will be given information by that company while you will go to their organization for work. Okay. So after doing this material requisition part, what will happen? This material requisition will go to the procurement team, and procurement team will offload this material requisition to different vendor or supplier. Now, suppose you are having one item XYZ like RTD. You are having RTD. So for RTD, there are 10 or 5 or 6 approved vendor are there. So the technical bid evaluation is a process through which we will analyze different vendor technical offer as per our requirements, that what are the vendor going to offer us and what is our actual requirement. Either the our requirement is going to be fulfilled by that vendor or not. So what are the guide for vendor offer review? Means how we will review this vendor offer. So the offer to be reviewed with respect to material requisition means what is our requirement and what is vendor is offering, that we should take care in our mind. What are the approved vendor list by the client? Means either the vendor which from which we are taking the technical quotation, either that vendor is approved in the client specification or not, either that vendor is approved by the client or not. Okay. If the manufacturer locations shall also be approved as per the vendor list. Okay. Okay, scope and interface clarity should be checked with the vendor offer. Okay, vendor to stamp and comply our material requisition specification, so that at the later stage vendor cannot deny, no, I have not read this specification and I am not aware about this thing. Technical queries, TQ means if any technical queries with us, so we can prepare a TQ and we will take the confirmation on that TQ from the vendor during this technical bid evaluation. Any deviation vendor is taking from your MR, that is material requisition, you can ask from the vendor, because vendor should specify that why he is taking any deviation and what is the impact of deviation, and they should give the clarification. Okay. Design changes to be covered as a part of TQ. If vendor is changing any design as per our requirements, so in that case, that should be covered in the technical queries. The TQ clarification point means the TQ which we will raise, technical queries which we will raise, the vendor has to give the clarification or give the proper justification answer of that TQ, and that TQ will be the part of this TBE. After this doing this thing, vendor clarification meeting if required, we will put those clarification meeting also. And after doing all these activity, we will close all the technical queries or technical clarification which we are doing with the vendor. Okay, so once we do the vendor offer review, which vendor offer review? The approved vendor offer review, which is approved in the manufacturer list. So once we will do this technical offer review, all the clarification, all the TQ points is clear, all the deviation points is clear, all the MR acceptance accepted by the vendor, everything is clear from the vendor offer side. So in after that, we will prepare the technical bid evaluation report, and then in that report, what we will do, we will compile all vendor offers. Suppose you are having 5 vendor, so we will compile all those 5 vendor offers at a one in one sheet, and we will see that what is our requirement, what is X, vendor number one is offering, what is vendor number two is offering, what is vendor number three is offering. Okay, so based on all the vendor offerings, we will compile all those report as per MR, and we will attach that technical query justification letter, deviation clarification which is given by the vendor. Okay, any deviation taken, that will be given by the vendor. Delivery time to be mentioned in the technical bid evaluation report, like in how many days vendor will give this material. Any technical acceptance or rejection by the vendor, that should be attached with technical bid report. And after doing all these activities, this technical bid evaluation report will be submitted to the client comment and approval. Client will also review and they will give their comments if they are having. Then after, we will approve this technical bid evaluation from our side, and it will be give to the purchase department for the further issue of procurement for commercial acceptance. Now, vendor that technical bid evaluation report will be issued to the procurement department. On the basis of this technical bid evaluation report, if we have selected 3 or 4 vendor, the procurement department will discuss with those 4 vendor for the commercial offer. And after doing all these things, vendor will finalize, and the purchase order will be issued to any particular one vendor who is suitable as per our technical as well as commercial point of view. Okay, now once the vendor receive the purchase order, So after that, the last stage which is available, that is called vendor document review stage. So in the vendor document review stage, we need to check all those drawing vendor documents, keeping in mind that what we had discussed during the technical bid, what is our requirement in the MR, means what we have written in our MR, what vendor has committed during the technical bid evaluation. Those things keep in our mind, and then we will review the vendor drawing. If there is any deviation from those points which we have discussed already, that is the MR requirement and the technical bid evaluation, during the technical bid evaluation time, so that may be commented from our side. If there is no such comment, so in that case we need to give the stamp copy, approved copy of this technical video drawing, technical drawing or documents which was issued from the vendor side. And once we will give the approved drawing from our vendor side, from our side, so in that case vendor will start the manufacturing of the material. And once the material will be manufactured, then after the inspection call will be raised by the vendor for factory acceptance test or witness of that material. So these are the vendor document review procedure. Like we have to review the vendor document and we have give the stamp copy, approved copy of the vendor document, so that vendor can start the manufacturing of the material. So guys, this is a short discussion over the temperature control in the oil and gas industry. Hope this session is very very important, very very informative for all of you, and you have enjoyed this session all about. And if you have any queries, you can write on our mail ID, that is info at the rate of peassociations.com. And for the course inquiry, if you if you would like to join our instrumentation design program, which is 50 hours course, which will just boost up your career, that will just make a big fly, big wings on your career, and you will be at the top of industry as an instrumentation design engineer. If you want to transform your career with us, with our team, we are 100% dedicated to give you complete online training on the instrumentation design and detail design engineering. So you can do this course inquiry at this number, and further our team will assist you to onboarding our upcoming session which is about to plan for the instrumentation design engineering training.